Have you heard about the two dragons, LessthAND and GreatOR? Have you? This is how you spell their names, okay? Less than, greater. No, this one's less than with a D, and this is GreatOR with an O. It's got this majestic GreatOR sound. And what makes these two guys different is their horns. Less than's horn, of course he has two, they go in like this. GreatOR's two horns go out. Which one is easier to slay? That's up to you, okay? I think people have an easier time with less than, so we're going to start with that one. And if you haven't figured this out already, we come up with less than and GreatOR when we're solving inequalities using absolute values. So instead of just a basic inequality like 2x plus 1 is less than 3, what if I gave you this absolute value of 2x plus 1 is less than 3? When we have an absolute value, that's when the dragons potentially come out. This one is a less than dragon because of that sign. Now this next step is what you need to do to slay the less than dragon. What we're going to do is we're going to split this up into a compound equation. If it's less than 3, the way we remove these absolute value brackets is we take that stuff on the inside, put it in the middle. This less than 3 goes there. And now I'm going to put the same inequality here and make this a negative. Okay? Let's think this through logically. This stuff on the inside, if it's less than 3, we're good. If it's greater than negative 3, and we take the absolute value, we get something that works out the same way. So we have to split it up in this way. We want something that's greater than negative 3, like negative 2, negative 1, and so on in those fractions, and less than 3. It's the only way it's going to work. Please notice I said between this and this. And now I see students split this up, but you don't need to. I know when we say we're solving for the x, we subtract 1 on both sides. We should say on all sides. It's just so rare you have more than 2 sides of an equation, but here you do, you have 3. And you can leave it in this compound equation form and keep solving. Negative 3 minus 1 is negative 4. I'm going to keep the direction of this sign because I'm just subtracting. We flip that when we multiply or divide by a negative. But I'm not multiplying or dividing by a negative here. 3 minus 1 is 2. I'm going to divide by a positive 2 all sides. X goes here. Negative 4 divided by 2 is negative 2. You see what we got here, okay? So it still has that compound form. But the x values that are between negative 2 and 1 are my answers. We'll often have you graph this thing. Negative 2 here, positive 1 here, 0 would be here. It's up to you if you want to put it in there. To me, it's not that important. But these are open, okay? It's not less than or equal to, so open circle here, open circle here. And remember less than's horns. They go in like this. So we draw the horns here, and now less than is showing itself. I guess 2 horns kind of touching each other is not as scary. It is a dragon, but it's not as scary as GreatOR. When does GreatOR show itself? Well, let's say I gave you the absolute value of 2x plus 1 is greater than 3. I'll make it greater or equal to give it black eyes. How sinister that would be. This is GreatOR. You need to recognize when the GreatOR dragon comes out for an absolute value inequality. The way we set it up is going to be different. It's a greater than symbol, so we're going to use OR. Instead of this compound equation where something was between something and something else, I need to split it up. 2 simple equations. First one looks just like this, but without the absolute value brackets. And then I write the word OR. And my second equation is going to look just the same except 2 changes. I flip the direction of the sign, and I take the opposite of that number. So instead of greater than or equal to 3, I'm going to make it less than or equal to a negative 3. This is how we slay GreatOR. And now we just solve them separately. Subtract 1 from both sides. 2x is greater than or equal to 2. Divide both sides by 2. X is greater or equal to 1. You can see on this, here's a 1, Make it solid. Greater than goes out in this direction. Okay. Or, let's find that other horn. Same thing really, but be careful here. 2x is less than or equal to negative 4. Divide both sides by 2. I get x is less than or equal to negative 2. So that negative 2 that's down here, solid I, goes to the left because it's less than or equal to. And there's GreatOR. To me, GreatOR looks scary, and I think it's a little more difficult. Students make more mistakes on this, not too many, but more on this than this one. But they're both dragons, and you slay them using this strategy when you're given an inequality with absolute value. One more thing I want to go over, and every student falls for this once, and sometimes more than once. Don't you fall for it. Absolute value of 2x plus 1 is less than negative 1. You might get so wrapped up in the idea of less than that you split it, you make it like this, you solve, you get an answer that doesn't make sense. But here's where common sense plays into it. Whatever this is, you're taking the absolute value of it. You take the absolute value of anything, it's going to be either 0 or positive. It can never be less than negative 1. This is no solution, sometimes written like this.